Hey, so let's start with some of the practice problems from the book. So we're going to be doing well, we're not going to be doing all of them, but we'll be doing some of them, but you guys should be doing all the problems from 1 to 6. I'm going to show you some of them. So let's start with 1 and let's do 1A. So in 1A, we have a matrix which is 813 401 603. Now notice the straight line. So we have a straight line here and a straight line here. So when we do this, like curved lines, okay, my handwriting is really bad. So if I do this or this means that we're dealing with a matrix. If we do this straight lines, that means we have a determinant. Okay, so we have to find the determinant of this 3 by 3 matrix. So once again, what we have to do is choose any row or any column. Now here's a trick that I did not talk about in the previous video, is that you can pick any row or any column as we have talked about. So if you pick this, for example, so let me write down what you have to do. You get an 8 and you get 0, 1, 0, 3 minus 1. You have 4, 1, 6, 3, and then I'm going to just get rid of this plus 3, and then 4, 0, 6, 0. And then you can easily calculate it. That's easy enough. But there's an easier way of doing that. So we have basically three options, 3 rows and 3 columns. So why not pick the row or the column that simplifies your task? What if we pick the second column? If we pick the second column, look what we have. So the 3 elements are 1, 0, 0. So we start with minus 1, and what we have is 4, 1, 6, 3, and then we have nothing because all the other elements are effectively 0. So we don't really need to worry about them. So we just have to calculate one determinant here. That is 4 times 3 plus 6 times 1. So what we get is minus 1. This is 12 plus 6. So 18. And let's do this as well, since we have set up the problem. So what we get here is 8. So 0 times 3 plus 1 times 0 minus 1. 12 plus 6 plus 3, effectively 0 plus 0. And so of course we get, do we get minus, oh sorry, this is minus 18, and we get minus 18. So the same thing, but whenever we have a situation like this and we're trying to, we have freedom to select one row or one column, pick the one that simplifies your task. For example, if we look at 1B, we have 4, 0, 2, 6, 0, 3, and 8, 2, 3. And once again, we are free to select any row or any column. So why not select this right here? And that would simplify our task a lot. We can select this, we can select this, but why make our task more difficult than it has to be? So I'm not solving B. I'm sure you guys can do that. I'm not solving anything else from part question 1. It's easy enough. Let's take a look at question 2. Determine the sign to be attached to the relevant. Okay, 2 you guys should do. 2 and 3, give it a go. All of you should be able to do. If you understand part 1, 2 and 3 is easy enough. Number 4. Okay, let's do number 4. I'll do A, and then you guys can do B. So we have a 4 by 4 matrix. We haven't looked at 4 by 4 matrices yet. So 2, 3, 4, 6, 1, 6, 0, minus 1, 0, minus 5, 0. Okay. So we can select any row, any column. So let's see which row or column will simplify our task. So for example, some of you may say this is quite easy because we just have 1 and 2 and the multiplication will be easy. By comparison, this looks like a relatively more difficult column. So there's a judgment call to be made, but I'm just going to go with this one because there are 2 zeros there. So if I do that, let's see what I get. The first element is 0. So we don't really need to worry about that. What we would get is 0 and then a bunch of stuff here. So now there's going to be a minus here, minus 5. And so now, since we're dealing with 5, this and this we do not look at. So what we have is 1, 0, 9, 2, 4, 6, 0, minus 1. And this is done. Okay. And then we have plus 0. And then since this is 0, we don't really need to worry about whatever is in here. Minus 8. Okay, this is getting a bit. Minus 8. And so once again, since we're looking at 8, we ignore this row and this column. And that leaves us with 1, 2, 0, 2, 3, 4, 1, 6, 0. Okay. So effectively what we have is a 5 here with 1, 0, 9, 2, 4, 6, 1, 0, minus 1, minus 8, 0, 3, 4, 1, 6, 0. And we can go back to the original size. Close enough. Okay. All right, now what do? We have a 3 by 3 matrix, 2 3 by 3 matrix. So once again, we have to calculate another determinant. And what I am going to do is I am going to select, well, let's take the first row. You can, the third row looks easy as well. I'll go with the first one. So I get 1, for 8, I'll pick the first row once again. Remember, you guys are free to pick whatever row or column that you want to. So 3, 4, 6, 0, minus 2, 2, 4, 1, 0. Let's close the bracket. This is equal to 5 times 1. What do we get here? Minus 4 plus 9. So 0 minus 4 minus 8 minus 24 minus 2. So effectively we have 5 minus 4 minus 36 minus 8. So minus 24 plus 8. 40 minus 8, this is minus 16. So how much do we get? Minus 200 plus 80 So 128. So the answer is 72 minus 72. And that's the. So you say it's a lengthy process. And then if you move on to a 5 by 5 matrix or a 6 by 6 matrix, it gets even lengthier. But the process, the step-by-step things that you have to do is exactly the same. So, if you see a big matrix in your exams, don't be freaked out. It just means that it's going to take longer than a smaller matrix. So that was number 4A. You guys try and do 4B. Try and do, okay, 5 and 6 you guys should be able to solve on your own as well. So give it a go. It should not be difficult if you understand what minors and cofactors are. That is all we're going to do from 5.2.